One other topic that you get into in trig part 2 here, which is going to be a topic that is really important in college algebra, trigonometry, and then pre-calculus, is the special triangles, right? The 45, 45, 90, and the 30, 60, 90 right triangles. So we'll just give you pictures and show you what they should look like. All right. So a 45, 45, 90 triangle is actually what is known as an isosceles right triangle, and an isosceles right triangle has two equal length legs. Right? That's pretty close, I guess, right? So you're saying that this leg here and this leg here are the same length. So if that happens, okay, if you have two equal length legs and you want to call each of those equal length legs 1, right? Because it makes sense to just call something 1, right, rather than, like 5 or a half or something like that. 1 makes a lot of sense. And then I use the Pythagorean theorem. I would have 1 squared plus 1 squared equals c squared. So I'd have 1 plus 1, which is 2, so 2 equals c squared. So I end up getting c equals the square root of 2. So the other side, right, the hypotenuse, ends up being the square root of 2. So there's my 45, 45, 90 right triangle, right, which is known as the isosceles right triangle because it has two equal legs, okay? And then the other triangle, which is the 30, 60, 90 triangle, the way that this is usually derived is what people do is they start with an equilateral triangle, and an equilateral triangle has 3 equal sides and 3 equal angles. Now that's not a great picture, but we'll assume that these sides here are all 2. Okay? And this is an equilateral triangle. So each of the angles here is a 60-degree angle. So this is 60, 60, 60. And then what you do is you draw an altitude down to the base here. And if you remember any geometry from high school, what does an altitude do when you draw it from the base of an isosceles triangle? I'm sorry, when you draw it to the base of an isosceles triangle, is it splits the base in half. So this and this are actually equal. So if the whole length was 2, each of these is actually going to be 1. And in addition to bisecting that side, right, if it cuts it in half, it's called bisecting, it also bisects this angle up here. And this angle up here was actually 60 degrees. So now the two angles that you formed up there are each 30 degrees. And then, of course, you've got a 60-degree angle here and a 60-degree angle here. So you have what are known as congruent triangles. Sorry, couldn't think of the word. Right? You have two congruent triangles there. They're identical triangles. So what do they look like? If I take the right-hand one out of there, right, the one on the right side there, I get something that looks like this. And if that was the 90-degree angle, this is the 60-degree angle, this is the 30-degree angle. So we had a 1 down here and we had a 2 over here. So what would this other leg be? Well, this is, again, you could use Pythagorean theorem. So the other leg squared, which is, call it, I guess, b, right? So I have 1 squared, which is the first leg, plus b squared equals the hypotenuse squared. I would end up with 1 plus b squared equals 4. So b squared is going to end up equaling 3. So b is really the square root of 3. So what does my 30, 60, 90 picture end up looking like? This. There's my 30, 60, 90 picture. Right? I've got a 1 opposite the 30-degree angle. I've got a radical 3 opposite the 60-degree angle. And then I have a 2 as the hypotenuse. And if you just know these two pictures, then finding the sine, cosine, and tangent of the 30, 60, and the 45-degree angles is simple. right? So what would the sine of 30 be? It would just be the opposite, which is 1, over the hypotenuse, which is 2. It's just 1 over 2. What would the cosine of 30 be? It would just be the adjacent, which is the square root of 3, over the hypotenuse, which is 2. So this is just the square root of 3 over 2. And what would the tangent of 30 be? It would be the opposite, which is 1, over the adjacent, which is the square root of 3. And then I can do the same thing with the sine of 60, the cosine of 60, and the tangent of 60. So again, remember what happens with, and we had talked about this in a previous video, the sine of 30 should be the same as the cosine of 60, because the opposite and the adjacent just switch. And then the cosine of 30 should be the same as the sine of 60. Right? So the sine of 60 is going to be the square root of 3 over 2, and the cosine of 60 is going to be 1/2. And the tangent of 60 is actually going to be opposite, which is the square root of 3, over adjacent, which is 1. So actually, when I go from the tangent of 30 to the tangent of 60, I end up having the reciprocal. And then, of course, the 45 angle is the easier one, because the triangle is simpler. The sine of 45, right? The sine of 45 degrees, this would be 45 degrees. I didn't write these in before. And that's 45 degrees. So the sine of 45 is the opposite over the hypotenuse, which is the 1 over the square root of 2. And then the cosine of 45 is actually going to be the same, right? The adjacent is the 1, and the hypotenuse is still the square root of 2. So it's 1 over the square root of 2 again. And then the tangent of 45 is actually going to be 1 over 1, right? Because when you look at the picture, the opposite is 1, and the adjacent is also 1. So you end up with 1 over 1, which is just 1, right? At this point, I'm just going to leave them all as fractions, because again, we want to think of these trig functions as ratios, right? They're ratios of lengths of sides in the right triangle, right? SOHCAHTOA, it's opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, so on and so forth. Okay? So those are the special triangles. And again, really what it comes down to is knowing what the pictures look like. If you know what those pictures look like, you should be in good shape, because then you can just look at them to evaluate all the trig functions.